So my name is Matthias. I'm a core maintainer of Kubescape. So Kubescape started in 2021 as a static scanner for your Kubernetes cluster. We were scanning your resources against some security frameworks. And I have some good news. So this year we reached incubation. We started as a sandbox and now we're an incubation project. So when I joined the project, it was like 2.5 years ago, more or less, and there was something new at that time. Well, not new, but like it was hot. It was eBPF. So we thought, how can we evolve from just scanning a cluster to include some eBPF goodies? So we said, let's start recording how applications behave, and then we can check if it's good or not, if there are some deviations. So it seems simple. So we wrote an agent using eBPF, which would like monitor the containers through the Linux kernel, and then just store all these behaviors as a CRD through the Kubernetes API. We even thought about writing our own storage component, which allows to have a separate place to store them, not in etcd. So it seems simple. However, at the very beginning, one of the CRD that we created was called application profile, and it was very simple. We would track only one container. We would only record execs and opens. However, when developers have a game, they start playing a lot. So then we started tracking not only one container, but all the containers of a workload. So init containers, ephemeral containers, all the containers. And instead of just the execs, we added the second profiles, the endpoints that the application is talking to, so the different images, the call stacks, policies. As a result, our CRD, instead of being 100K, became 100 megs. So as you can imagine, it caused some issues. So I'm going to tell a little bit of them so you have the whole story on how we developed this feature. So first, about the eBPF library. So we started using the Falco libs, which were good because they were compatible with older Linux kernels. Unfortunately, since it's old eBPF technology, we were using a lot of CPU and a lot of memory. So we moved to the inspector gadget libs, which are like much better because using newer eBPF libraries. As I told you, we were implementing our own API server, but instead of using the sample API server, we modified it heavily. First modification, obviously, to store 100 megs, you cannot really store them in etcd. So instead of using etcd, we started to use files and then a SQLite database to be able to get the metadata fast. And we had to implement a direct IO driver to avoid having all those files loaded in the memory cache of the Linux kernel. Then instead of sending full objects back and forth between the agents and the storage, we started to only send diffs, which has the two benefits. First, you are not sending 100 megs every time. And second, each agent doesn't need to remember what he sent. He just like sends what he sees during like a short amount of time, and then he can flush the memory. And then finally, we got rid of JSON. So the sample API server only uses JSON, so we shoehorn into it gRPC. And instead of using 600 or 700 megs of memory to unmarshal a JSON, we just use like the size of the CRD, so a few hundreds. So gRPC was really like a good improvement. So you can reach us at the Project Pavilion. We are there every morning. 18A, so tomorrow, Thursday, and Friday. And there is a talk on Friday afternoon during the Contrib Fest. Thank you.